Welcome to this lecture. So let me start by showing you one quick thing. If you go to the web page for lecture 12, okay, you will find that there all the material I put up for services. So you will find the example of the app that we will be discussing today, which is a prosecution of what we did last time. Okay, you will find the slide deck and also some other documentation. Okay, so essentially this summarizes what we did last time and also this time. So the resources are all there. Okay. So I wanted actually to begin from the slide deck as a way to show you in a visual way the interaction between an activity and the service. Okay, so let me actually I want to start from slide 1. So the claiming a service in the manifest, I think you have already seen it. You need a service entry that describes the name of the service, so the name of the class, and whether we want to export it or not, and possibly what is the icon and label of the service, even though I actually have not seen much use for an icon and a label for a service. Okay. Perhaps that's useful when you use it, when you look at the list of running services, maybe that's where it appears. So as I told you, there are two types of services, bound and started. Started services, you decide when they start and you decide when they stop, okay, and they run in the meantime. And you have to provide a notification to stop them for the user to be able to stop them, okay? Bound services are always available, and when somebody wants to use them, they bind to them and start using them, and when you unbind, you stop using them, and the service is running as long as there is at least one app that is bound to them. Okay, so they're essentially by request, and you are more likely, I believe, to write started services, because those are the ones that your app starts in order to be able to use them, even when your app is not on the top of the phone, right? Even when your app is not active. So these I told you already. This is just a bit of summary, so I don't want to do more on it. I just want to mention one thing. There is another type of service. It's called an intent service. I have never had use for it, but it is the simplest type. It's essentially a very simplified service. You give it an intent that describes what to do. For example, upload this file, in which you attach the file location to the intent for the service, and the service actually manages a queue of intents, so a queue of stuff to do. It will create a thread in which to do what you ask it to do. It will do what you want it to do, and it will stop all by itself. Okay, so it's a very, very easy way to initiate long-running activities. The real drawback is that this intent service doesn't give you a particularly good way of keeping something active for the long term and communicating back to your activity. But if you just want to use an intent a service in order to do something that takes long time and you want it done and you don't care so much about the result, this may be a good way to do it. Okay, and so in order to do it, you say this is code copied from the Android documentation. You can create a hello intent service which extends intent service, and essentially the only thing you have to do is override this onHandle intent method. Okay, so when there is a new intent that the main application sends you, it will be passed to you here, and you can do whatever you want. Here we are just waiting, but you can do whatever you want. Okay, so it's the simplest type of service because you don't need to manage the threads. Okay, everything is done for you here, essentially, in a single piece. Okay, so this is not the way we are using services in our class example, and so I have this is a service life cycle. I just wanted to be here for reference, but we saw it last time. Rather, I want to go into this, which is really a summary of what we are doing. So we are using a started service, and it works like this. there are essentially three players, as I mentioned last time. There is the activity, there is the service, and there is a service task, which is which implements runnable, and it will be run in its own thread, right? So let's look at what happens. So the activity calls start service. This calls on create on the service. Now the service is created, but typically you want to run what runs in the service in its own thread, right? That's our whole goal. Because here, in fact, in these slides, I color orange everything that runs in the service thread. Okay, and everything that is white is still running in the UI thread. So if you call on create on a service, it's great, but you still are in the UI thread. Okay. Now you create a new thread and you say thread start. This will start running the thread that you define in your service. Okay, so that's how it is done. It's the service class that has to create and start a thread. Okay. Now, once you create this service, there is this semi-annoying fact that you would like to essentially, and in fact for our applications it would have been an easier implementation if the act of sending a start service intent would somehow return to you the service object that you created, right? But this is not what happens, because the services are a very general concept in Android. So what happens is that when you start a service, you start it and then it's there running somewhere and you don't know where it is. You don't have a reference to it. So you need to call bind intent. This will call this will essentially activate this binder extension that you have to define in your service, and it will return. It will return what you want, okay? But I define a method getService. Typically, this is my shortcut. I mean, it's not only mine. Many people use it. In this binder that I return, I define a getService method that returns the service object itself. So that in the main thread, I can say my binder is equal to my binder service binder. Okay, fine, great. My service is equal to binder getService. Okay, and then I use a flag to keep track of the fact that now I'm bound to the service. So this is, this sort of boring code, because the service does not even want to reply with me with itself. It returns this generic binder object that would act as intermediate interface sitting here, between the activity and the service. And I find this, overcomplicated for the goal at hand. And so I just return a reference. I just use this getService to return a reference to the service itself. So once we have a reference to the service, you can do myService.foo. This, what happens? This calls the foo method in the service. Now maybe your task has a task foo, and so in the foo method of the service, you can say myTask.taskFoo, where my task is the task you have created, right, to run in its thread. Now, you have to be aware of the fact that if you do this, if you say myTask.taskFoo, taskFoo does run, but it runs in the UI thread still. So there is this thing that one has to keep very clear. I don't know how clear it is to you, but actually, how many of you have done real multi-threaded programming so far? Raise your hand if you have done that. 1. Okay. 2. Okay. Great. Okay, for you this may be semi-known, okay, or maybe well-known, in fact, but probably not for the others. So one of the things that confuses at least me a lot whenever I use threads is the following, okay? That you would like that the boundary of threads is also the boundary of objects or classes, right? It would be intuitive in some way, even though it's not really what happens at all, if when you are here, and you say myTask.taskFoo, this call to foo happened in the thread that runs the task. No? But the thing is not like that at all, right? So when you call something, that may be an object boundary or a class boundary, but it's not a thread boundary at all. The call happens in the same thread in which you are. Okay? So for example, you have to be careful, because suppose that what you're doing here is that you want to give some data to the service, and they say, my service, get this number 3. And so you say public void, get the number, pass the number to the other one, and then you pass it. And now here you want to store this number 3 in a private variable of the task. Okay, you have to be careful about synchronization, because the task is running in its own thread. It might be accessing that variable, and now you are trying to change it from another thread. Okay, so if you want to access stuff in this task 2, you have to use some synchronization method. Either you make that method synchronized, but then you might need to make another. So, how many of you actually know about synchronization in Java? Very, very few. Okay. So, sorry?
Use monitors, right?
Use
monitors to do synchronization.
You could, but actually, let me go in this way. So, in Java, some things are okay without any synchronization. You have to look at the Java memory model. But for example, changing value to a Boolean or to an integer is allowed. Also to a float, I believe. Okay, even to doubles if you declare them as volatile. Okay, so a lot of the time, so for example, you have seen me saying my service dot please finish. That calls public void should finish, my task dot should finish, and here I say active is equal to false. I mean there. Okay, so I am essentially modifying a Boolean variable in another thread. That's perfectly fine. Okay, the right to Boolean values is atomic, and so there is no problem with it in Java. Okay, a lot of times. You are doing accesses to data types that support atomicity, such as integers or booleans, but you do a read and write. So if you don't protect it by some kind of synchronization primitive, you may end up into trouble. But a lot of times you don't care about the trouble. Okay, so I mean, if you want to pay a little bit, it's often the case in which. It's sometimes the case in which you simply do not need any synchronization for simple things. Okay, the synchronization really comes in when you have to examine and change data structures that require consistency, or when you change objects that are not atomic data types in Java. Okay, we will see later methods for communicating. If you need to modify. If you need to modify some shared variables, what I often do that may not be the optimal solution that others may want to use is that I use something like, well, let me write here so that everybody has it. I think. Hold on. What I often do is, for example, object. I don't know, private object. My lock, okay, is equal to new object. So I simply grab any new object that I use as lock, right? And then I can do synchronized mlock, okay, and here I can write what I want. And if I use always the same lock, this is a very simple solution, but essentially in a service, you only have to deal with the thread that belongs to the service itself, and with the thread, the UI thread that is trying typically to change some simple values inside the object. So if you are careful about doing something like this, whenever you access those variables that are shared from the two threads, this may be all that is needed. Okay, I will later go into better mechanisms for synchronization. We will be doing them in the rest of the class. But this is otherwise a simple method that you can do. Have you studied locks in operating systems? Yes, no? So essentially a lock means this. It's like a private token, In order to be able to be in the section of code, you have to have that lock. Okay? And there can be only one lock holder at any given time. So only one thread can hold the lock at any given time. So if you have some shared data structure that you want to touch, you can first grab the lock, by working inside that. Whenever you are syntactically inside that place, you are holding the lock. Okay. So if somebody else has a lock and you are about to execute that synchronize them lock, what the Java execution model does is that it lets you wait until the other thread is finished and out of that section before you can enter. Okay, so it's called a mutual exclusion section for those of you who have not seen it. Okay, so so you use this simple mechanism as a sort of easy way to write to modify simple variables. I will tell you in a moment better ways to organize a larger scale communication between a service and the main thread. Okay, but if you just want to modify some indicator or flags, as I say, flags that are Boolean or integer, which in my experience is the case quite often, you can just modify them without holding any lock. Okay, because if I write B, so there is this problem, of course. Suppose my code says the following. Suppose I don't use a lock and I say something like, B is equal to, like you have a public void, I don't know, set params, and you pass to it a Boolean B and an int I, just to be full of fantasy for the variable names, I guess. But inside here you say my flag is equal to B and my int is equal to I, something like that, where my flag and my int are private variables of the service task. Okay, so if you do something like this, you should notice that there is no guarantee that the task will see these flags after they both have been updated. Right? I mean, the task could come in between where we have updated my flag and not my int. All you know from the Java memory model is that the write to any one of those two is atomic, which is good, because if it were not true, you could end up, in a lot of trouble if the integer was written 1 byte at a time, and you were reading some bytes of the old and some bytes of the new integer. Okay. Now, I personally find that in the code I write for mobile, the fact that you might read B and not I sometimes is not so bad, because a lot of the code I write for mobile is written in this assumption that I update things on a best effort way. Maybe B and I is gotten from the server, and I have no idea whether the server actually gave me both B and I in a consistent way. So a lot of the time, I mean, I generally look at it, but a lot of the times I don't care if you read the new value of B but the old value of I. If you do care, you have to put these instead into a synchronization block. Okay, and also access those in a synchronized way when you need them both. Okay, unless you use other primitives. Okay, so let me go back to the slides a moment. Sorry, I think I was here. Okay, so so great. So this is a way to create a service connection. How do you stop the service? Well, when you say stop service intent, this will cause a call to onDestroy in the service. And so what you do is myTask.stopWork. This call to myTask.stopWork will say will say alive is equal to false. And in my task, maybe I have something like while alive do stuff. So essentially, I do alive is equal to false without holding any lock, because as I told you, I can change Boolean values without worrying about synchronization. And so I never kill a thread, right? As I told you last time, I just tell the thread that it should finish, and the thread will be kind enough to finish. Okay? And actually, this is a mistake that I made, because if you allow me to edit the slide very quickly, this is actually outside of the service thread. Yeah, that was a bad mistake. Okay, so that happens outside. So this is a real picture. Okay, so let's look at the next slide. So the problem is this. Okay, and this is the fact we didn't do the other time. now we have a service, we have a handle to the service, and I can actually call simple methods of the service. I haven't told you yet how to do a beautiful communication between the service and the activity. But the problem is more the other way around. That is, what is a really good way to have data passed from the service to us, to the activity? We have the activity in this case, okay? The problem is a little bit this, that the activity has a reference to the service. But the service does not really have any reference to the activity. Okay? In fact, often the activity does not, the service does not is not particularly told who is binding to it. Okay? The service actually does not have a call available that gives it the set of binders, the set of the activities that bind to it. So we need to find some other way for the activity, for the service to be able to talk to the activity. So we have to essentially reverse the communication, right? It's easy for the activity to call the service, but now we need the service to call the activity. How do we do that? We use a paradigm that is very well known in computer science. Essentially, it's called the publish-subscribe, okay? There is a publisher of information, and people can, or users can subscribe to it, so that when new information becomes available, they are passed that information, okay? Have you heard of publish-subscribe? Probably for RSS feeds and the like, I guess. But this is an incredibly common and incredibly important paradigm in building software, okay? You have some process that generates information that may be useful to many, and you wanted that information to reach a potentially variable number of listeners. Okay, imagine a very different application. I'm making it up, okay, because I don't know how they do in a Mac laptop the battery management. Okay, but I guess a lot of apps may be interested in knowing the battery level. Okay, so there is some place where the battery level is known and is analyzed because you don't want the laptop to overheat and et cetera, et cetera. I'm sure that there is somewhere an OS process that watches the battery. Okay, so a way to implement that, I have no idea whether that's what's done, but would be that your application can subscribe to the updates on the battery level. Okay, so the call to subscribe is initiated by the listener, which in this case it suits us well, right? Because the listener is the app, and the app has a reference to the service. So that's what we do. So it works in this way, okay? This is not standard, it's our decision, but we will be defining an add result callback call. Essentially, the service will keep a list of the people who want to listen to the updates, okay? And we will define a method that is called add result callback, okay? So that if you pass a callback, so if you pass something that can be called back when there are results to the service will be able to notify you when there is new stuff for you, okay? It's like giving you my business card, no? I'm giving you a callback, my business card is like a callback, okay? And you keep your stack of business cards so that when you have a new result, you know which phone calls to make to tell people that there is a novelty, okay? It's the same principle, essentially. So, again, this goes through a couple of calls. So, my service add result callback main activity.this. So I'm passing directly the activity. It's a convenient thing to do. I'm passing directly the activity object as a callback. Okay? The service says it simply passes it through. You know, there is this boring thing that you call the service, and then the service has to call the method in the service task that is running, right, in the thread. And now, add result callback, RCB, this will add a callback to the result. Now, adding a result to a call, adding an element to a list is a dangerous operation for concurrency. It's not like setting a Boolean. And notice that there can be many callers, and these each happen in the thread of the caller. At any rate, it doesn't happen certainly in the thread of the service itself, right? So how do you cope with that? Well, Java has some synchronized data structures that you can use so that you can update them, and they're inherently kept in a synchronized state. So it's as if they, all the methods you call on them, they know how to lock the structure before they modify it, so that the modifications and the reads are consistent. This is one of the beauties of Java for multi-threaded code, okay? So we will be using this result callback add, this is an object, we will see the details in the code later, but this is an object on which these calls happen in a synchronized way, so that there is no worry about corrupting the internal state of it. Okay? So all this does is essentially the activity passes a reference to itself to the task, so that the task can call it back when there is any result. Clear so far? Eh? It's not particularly straightforward, so if you have questions, then I will also show you in the code, okay, how this works in detail. But okay so far? Okay. How do you send stuff from the service to the activity? So now we are inside of the service, okay? We are running. Actually, I made a. Let me do a small change to this slide again. Sorry, I noticed these errors when I make the slides. Let me put this notify result inside of that loop. I think it's a slightly more interesting example. Okay. So this is what happens, okay? You are running in the thread of the service, and from time to time you have a new piece of result that is ready. So what do? You call a method notify result R. Your intent is to broadcast to R to every listener. Now, I'm giving you a slightly more general solution that you need for this example, because typically you will have only one listener, okay? But it's not actually completely true, because suppose that your app has many activities. Then every activity might need to register itself. So maybe at every given time you have only one service, but it's easier to write general code that doesn't break if you have more than one listener, I guess. Okay. Anyway, so the service thread, when you call notify result, this notify result R, this method called on result of the object that you enqueued to it, so of the activity. So the on result of the activity method is called. So now we are doing this funny thing. We are executing some code of our activity on result R in the thread of the service. Okay? Which is great, but only partly, because it's not what we typically want to do. Remember, all the rest of the activity, unless you do these async tasks, is running in the UI thread. And so you can happily write all the code you want, knowing that there is no synchronization problem of mutual access to shared variables, etc. Okay? So now we are breaking these, because now we have some place in our activity that is actually running in another thread, this on result. Okay? That's not so we need somehow to pass a message to ourselves to make the same information pop out in the right thread, in the UI thread. We need essentially to transmit within the same object, but we need to transmit information from the service thread to the UI thread. And we do this by relying on a general message passing mechanism that is available in Android. Okay, so essentially we build this I think was truncated. Fine, you will see it in the code. But you get a handler. A handler, as I will show you in a moment in the documentation. But a handler is an object that enables you to send messages and to retrieve messages on the other side. Okay, so you get a handler, and you call the send message method of this handler, passing it the message you want to send. The handler, UI callback, okay, this MUI handler is a UI callback, okay, instance, so you will see it in the code. But this handler, when it receives a message, will execute a handle message of M, and so here you finally, after all this incredible path, you are in the UI thread and with the result of the task. So now you finally can update your own UI. Okay? So there is this complicated passage, okay, to have the service give you information. You need to first register with it, then the service will call back one of your methods. It will call it back in his own thread, okay? and you need to generate a message and send it to a handler that will handle the message in your main thread. Okay, I think now is probably the point to see this going on in the code, so that it's a bit more precise. To make it fit on the slide, I had to remove some of the. Sorry, this is not needed. Remove some of the complication. Okay, so let me put these windows in the right order so that we have, there is the activity, the service, and the service task. So let's look at the activity first. This is what we saw last time, but a little bit enlarged. So this handler, I define it as a MUI handler, is a handler, and I initialize it on the basis of a looper, okay? And I give it the UI callback as the callback. The looper, I tell you later what it is. Okay, for the moment, forget the looper, otherwise we get confused, okay? Forget what the looper is, but I'm giving this callback, okay? Now, let's look at the flow. On the resume, I create an intent here, and I start the service for the intent, and I bind the service. When I bind the service, essentially, I create an intent, and I ask to be bound to the service with a callback that is called service connection. Sorry, all this long stuff. But on service connected, okay, when the service is connected, I get the binder, I get my service via my call to binder get service, and I'm done. Okay, so this is the point at which we were last time in the last class. Okay, I started a service, I asked for the binder to that service. From the binder, I call get service, and I get finally a reference to the service. Fine. Okay, great. Okay. Now I do one more thing. I call my service add result callback of main activity this. This is what I told you now. I'm telling you the service that if it needs to call me back with any results, I'm registering to the updates that will be coming from the service. Okay. So let's follow a moment what this code does in my service. In my service, again, on start command, what I do is this: I start a thread, right? Okay, so. Actually, it should not be important to start the thread there, but because I already started in onCreate. But in onCreate, I instantiated the task, which is my service task. Okay, I create a thread to run it, and I started the thread. Okay. Then, so essentially, this is just oh boy, this is old code. We start the task thread. Okay, this is just for safety. Okay, okay, this return type to the start command is important, and you can return many different return types. So let me comment on it a moment. If you return, I'm sorry, I hate that it stays highlighted. If you return start sticky, it means this: that if your service dies, Android will try to restart it every now and then, every few minutes. Okay. This is incredibly useful because your task may die due to many things. Maybe garbage collection that doesn't collect enough garbage. Maybe the phone is low on battery and Android decides to stop to kill some stuff. Or maybe you have a very rare bug. But suppose that there is a very rare bug in your Gmail synchronization service that runs in the background. You don't want to be off forever since, right? You would like the phone to try to restart it because if it's a strange bug, often it doesn't happen every time. Maybe it's related to the network going down at the wrong moment, whatever, no? So if you return start sticky, Android will try to restart your service. there are other return values that you can return. So, for example, you can return, I forgot how it is called, but there is another value that says, I want to start, but if I die, let me be dead. Okay, don't try to raise me back. No resuscitation. Okay. So on destroy, you simply stop. Okay, and I told you that also that when you start a started service, you need to create an intent that you put on the phone so that people actually can get hold of your service. Okay, and that is done in a method that I have here at the bottom, which is called show notification. This method is called I created a notification in non-create. Okay, so that people can actually access the service and do something with it if they wish. Okay. Of course, if your activity on top, this is not needed, this notification. But the idea of this started service is that your activity may not be running anymore, but the service is still running. And so, people need to have a way to access what to call back, to be notified that you're using the CPU essentially, and to start your activity quickly again, so that they can control what's happened. Okay. Okay. So, okay. Now, this is okay for one part of the computation. Now, once this thread starts, what do I do? In my service, so this is a thread, okay, and I wrote the simplest possible code that I could. So this is the actual thread, my task, sorry, where is it? My service task implements runnable, right, so that it has a run method. Runnables are the objects in Java that you can actually call to run, okay? So this implements runnable, and in the run method, what does it do? It says it's running, it keeps its own flag, and while running is true, it does the following, okay? Sleeps for 1 second, okay? Then generates a random integer, and then it wants to send this random integer to the activity. This is, the simplest thing I could code in order to try to pass a value back to the activity. So when it has this value integer R ready, it calls notify result callback, okay? Let's see how this works, this notify result callback. So in the service task, we need to do this. We need to keep a list of listeners, and then we need to notify them, okay? So this is the list of listeners, result callbacks. Sorry, it becomes dark every time I click. I should use another color. I'll define change color another time, I guess. Well, maybe I can change now, actually. If I find it immediately, I think it's easy to find, or it should be easy. So color, appearance, colors and fonts, or maybe occurrence, in fact. Okay, Java, mark occurrence, annotations, color, so you learn how to do it for your own. Because in general, actually, they are not visible, the occurrences on the bar. So and I find it very useful. So I don't know, what color do we like? This one? I don't like any. Okay, at least it will be lighter. Fine. So let's look at these result callbacks. These result callbacks are defined at the top, okay? And the result callbacks is an element of collections.synchronized set, okay? So it's a synchronized set of callbacks. This is a Java data structure that is synchronized, meaning that it can be used for multiple threads, but maintains its own internal consistency. Okay. So here maybe I should split the line so that you can see what it does. But essentially, it's you see the general type in Java is set results callback, because the general type does not care that the implementation is synchronized. But the implementation of this generic set is a synchronized set that contains a new hash set of results callback. Okay. Then I also keep, in general, a concurrent linked queue of service results. So how do I give a result back? In general, you don't only want to pass an integer, right? In general, you want to pass something more complicated, and something more complicated in Java is always an object. So I want to be sending back from the service to the activity, not a single integer, but an object, and I define the type that is called service result. This service result is defined here, and it's the simplest possible thing you can imagine. It contains an integer value, okay? Nothing more than that. But I just wanted to give you the more general code so that you can easily extend it to your need, okay? So why am I keeping a list of free results? Because in general, or at least it often happened to me, that I do not want to allocate a new object every time I have to return a result. I want to try to keep a pool of available objects that can be filled in with what I want to return. Okay? Maybe not every one of you needs to do that, but I was doing it because this code is originally taken from code I wrote in order to return images to the UI thread. Okay, and I did not want to have a bitmap object that I created each time. I wanted to have a reusable bitmap objects because this would generate much less trash around for the garbage collection. Okay. So if you don't need this sophistication, you can remove it, but it does not have to, okay? So essentially, this is the trick. I keep these result callbacks, which is the set of all the people who need to know about my results, okay? So now, how is the callback code implemented? It's not very complicated. Okay, so here there is add result callback, by the way. I say result callbacks, add this result callback. You will be wondering, hey, what on earth is this result callback? Okay? And now I tell you, it's an interface, so it's any object that implements the method on result ready. Okay? So I'm collecting a list of addresses, but these addresses cannot be any object. I need to be able to call them back when something is ready. So I define this interface that says result callback, I call this interface, okay? And the method that all these objects have to implement is called onResultReady, okay? Because when I want to notify everybody, this is a function where I notify everybody. When I want to notify everybody, what I do, if there is anybody listening, okay? Leave these lines for later. I'm essentially creating some buffer of free results, some buffer of free objects that I can use for returning, okay? But then I'm doing the following. I pick a free element where to put my result, okay? This if result is different from null is just for safety. I say result.integer value is equal to I, so I fill in this result to be passed back to the listener, okay? And then for everybody who is listening, I call them back and I give them this result. Okay? So this is essentially the place in the service where I'm taking this result and I'm broadcasting it back. Is it clear? I mean, I know it's a bit complicated, right? There are many pieces to it. So if you have questions, stop me and ask. Yeah?
Where are you broadcasting that?
I'm broadcasting it to the only activity that registered to. Okay, so I'm broadcasting to a public of one. Okay, and the public of one is here. Let me show you where it's done. Okay. Sorry. Here, you see, I say my service add result callback main activity this. So once the main activity has been able to connect to the service, it says, please register myself to you for updates. This is where you register. Okay? So, in fact, this activity, if it was suppose that you have two activities, but only one service running, when you execute on pause for one activity, you should unregister yourself from the updates. Otherwise, horrible things happen. Okay? Because if you don't unregister yourself, what happens? It happens that you, as an activity, die. You are not there anymore, right? But you have passed a pointer to yourself to the service, so the service will try to call you. And with this will obviously create an error, because you're trying to call a thread that doesn't exist anymore. Okay, so in fact, if you see that in the onPause method here, okay, if my service is not null, so I want to check, well, it's obvious, I want to avoid a null pointer, if by some reason, the service has died or whatever, but fine. But if the service I'm still connected to it, then I remove the result callback. Okay, because I don't want to receive callbacks after I'm no longer running. Yes. No, that's the problem. That you can't really. The only reference that you have in the service to the activity is main activity.this. But if that object is recalled, then you have a reference to something that's not there anymore. That's the trouble. Yeah. Actually, I'm not exactly sure what happens, okay? Because Java will not deallocate your object if there is a reference to it, the Java garbage collector. But your activity will be in a stopped state. And so I think, but I have not verified. I mean, I know that once I got it wrong and I got an error, but I don't remember what the error was, okay? But the error has the flavor of that you are calling a method of an activity that is dead. It may be said in a more cryptic way, so I may have gone in loops for a while to figure out what I was doing wrong. Because of course, you think you're always deregistering yourself, but there was a code path in which I was not, something like that. The error is not necessarily obvious. Okay. So okay, so fine. So let me go back to the service task. Okay, here we broadcast by calling the onResultReady method. Everybody who registers, because they abide by this interface, they need to have this onResultReady method. So now I'm calling the activity which needs to have this onResultReady method. Okay? So if I go to my main activity, I should see that somewhere there is this onResultReady method. In fact, it's here. Okay, when I declared the activity at the top, let me go to the top just one moment, but when I declared the activity at the top, I say that these implements com examples service example my service task with a result callback. So here I had to define that my activity implements that interface so that it can listen to the results that come back. Okay. In fact, if here I remove these methods, instead of I say, I mistype it, I get an error here, I guess. Okay, I get this method because of the override, but I also get an error at the very top that says the type of main activity must implement the inherited abstract method on the result ready. Okay, so if I register myself and I abide this interface, I need to implement that method. So let me go fix it now and do the typo. Okay, what do you do when you have a result ready? So again, the problem is this one. Okay, that now where I am in the service thread, and I need to talk instead to the main thread, to the UI thread. So I need to craft a message that the main thread will receive. So here is where the looper comes back into place. Okay, I define this MUI handler. I define it somewhere on top. Okay, here. There is this MUI handler. Okay, and I define it as a new handler of getMainLooper new UI callback. Now I can tell you a moment what the getMainLooper is. The main looper of the UI thread. I will tell you what loopers are later, because otherwise we generate even more confusion. But I say that MUI handler essentially can accept messages and will pass them to a UI callback. This UI callback is the place where the message will arrive, okay? And the UI callback is defined here. So essentially here in onResultReady, you get the MUI handler and you obtain a message and you send it. The message will contain a result, okay? So essentially you are taking this result that is passed to you here as an argument, right? You are given the result as an argument, I log it, but then I immediately craft a message that I send to its target, which is UI callback. By the way, I defined this handler. Okay, handler is a handler that delivers messages to UI callback. By the way, I defined it. When I am in UI callback, I can finally handle messages. Messages have an integer type. This display number is simply 10. I don't know why I defined 10. Okay, I mean just like that. Okay, I could have given 11, it would have been the same. But essentially, when you send messages, since you send an object, the receiver does not know which kind of object that is or how to cast it back to something useful. So every message has an integer tag. So you say if message.what is equal to display number, then I take message.object, I cast it back to a result, service result, and then finally I take this little integer that is in result into value, and I display it. So at the end, all these lines of code finally moved the integer from one place to the other. Okay? I see some of you shaking the head, and I kind of sympathize with that. And the reason I'm giving you this code, by the way, is not that I'm particularly mad or obsessive, okay? But it's that it's not particularly widely available. And so, if I were not showing it to you, there is no really very good way to see this all working in one single shot. How to create a service and pass the information back and forth, okay? There is an example of how to create a service. I haven't seen really the example of how to nicely pipe information from the service to the application, okay? I mean, I've seen it in some place, but I had to do a large amount of cleanup work myself to get something that is this simple, so to say, okay? So yeah, bear with it, but it may, if you do develop for Android, this might come quite useful to you, unfortunately. I'm sorry there is no shortcut. So now I want to sort of try to run this for you a moment, okay? But are there any questions at this point? Yeah. We can.
Mr. Lavo, what does the send to target function do for the MUI handler?
Okay, can you just accept for a moment that it just sends it from here to here? And then I want to explain you loopers later, just because otherwise, I mean, we already have quite too much stuff on the plate, and I just want to remove messages and loopers a moment. I will talk about them either this time or next time, and that will be the conclusion of this. But if you have other questions, I mean, please ask everything possible. I perfectly realize that this is quite messy. And I already worked quite a good time in order to cut it down to the minimum possible size. So we need to really understand this, essentially. There is no better way, I'm afraid. So let me show you what happens when I run this code, okay? So here I have a phone. Actually, the phone will be doing something incredibly boring. But let me just trace for you the logging, because the log messages are more interesting to look at than the phone. The phone will simply display random numbers on the screen. But let me show you what happens. Okay, so there is, my service task here, where I generate a random number, and so I will log sending random number, and I will log it. Okay, so one log that we will see is sending random number. This is generated from the service. Okay. Now, another log that we have, actually, let me just highlight the logs. Another log that we have is, okay, we have some logs for adding the result callbacks, etc. Okay, and removing the result callback. It's always very good to add these logs because, you know, once you cannot find your own service, you will want to know whether you have already bound to it or not, or what. Okay, fine. But here, you know, in the code that says notify result callback, actually here I don't have any log. Maybe I can put here another log. Okay. I can say, for example, log.i log tag calling result callback for, okay, result.int value. Okay, so I add one more log here just to follow what's happening. Okay, once this is logged, this should zoom back to the main activity. In the main activity, okay, we are calling on result ready, so we should see this log preparing a message for, and again I give the number of the random number I generated, and then we should see if everything goes fine, that here we say displaying, and we display the number. Okay, so if everything goes fine, we see this various sequence of messages. Okay, so I mean this went fine in my office, so of course it will break here. No, I hope not, but you know, you never know. I'm running this on a real phone. I don't know why, just to be faster, or perhaps because yeah, I trust more phones in the end as execution machines. It's much faster to get it to run as well. Okay, so it's building it. Don't look at that red stuff. That red stuff is simply because it's complaining either Huawei phone is complaining for some other thing. Sorry, let me. Okay, so this is what's going on. If I want to stop, I can click here, as you probably know. Now look at these. We need to look in detail to appreciate what's happening. Okay, so look, sending random number 18. This line happens in thread ID 8447. 8447 is our service thread. Calling result for back for 18, always in 8447. Then preparing a message for 18, we are still in 8447. When we display 18, we are in 8434. This is the main UI thread for that application. Okay. Releasing result holder for 18. This is another log that I have in the main thread. Freeing result holder for 18. I will show you where these logs are, where these things happen. Okay, I will show you where these calls happen to free the results. But this happened in the UI thread. Then we go back. You know, after sleeping for a while, let me show you the timer associated with it. You see, this message passing that looks so complicated to you, it's less than a millisecond. Okay, it always all of this happens in the same millisecond. I don't know how much it actually takes. I think it's some microseconds. I mean, it is optimized for this. My guess is, you know, probably I don't know how fast the CPU is. Some 50 microseconds, maybe 100. I don't know. I am shooting really. I don't know. Okay, but it's efficient and fast. Okay. Now, let me tell you what this freeing business is. Okay, so this in the meantime is going on to generate random numbers. And if you want to look at what the phone is doing, we can. If it hasn't gone to sleep, it probably has gone to sleep. Don't you hate when things sleep without your permission? Oh, I said light off. You see, there is a tiny random number. All this effort for that, but we get it from a service. Isn't it impressive? Okay? Yes. Well, you know, it could be playing music to us. Come on. No? Be optimistic. Okay? So so back to the laptop view. So once I get a message, okay, you see I say displaying the number. And then if the service is still bound, sorry, if the service is still bound and my service is not null, I do all these things because I never, there is a way for your callback to receive a callback, the binder to receive a callback that your service has died. And the problem is that if the service dies, then your binder becomes, you know, you cannot talk to it anymore. So you should all the time check whether your service is still alive, unfortunately. It's a, you know, Java is a well-typed language, but null pointers are still the most common way to crash your application, and they usually happen because you have an object you believe it still exists, and somebody has taken it away from under your feet. You know, and this is a very typical case. You talk back to the service, but the service might have died, so you need to check. Okay, but otherwise, I call my service release result. Now, my service release result happens not in the service task. It happens here, okay, in the service object. That says, release result calls my task release result. Very interesting code, yes, I know. And my service task release result is somewhere here. And all I do is I free results offer R. If you look at the implementation of synchronized linked queues, you know, they're meant to store a pool of objects, and you offer them one more thing for the pool, and I forgot how it is. You take, I request, you borrow, you something. Here, you poll to get one of the elements of these. Okay? So they're essentially meant for implementing pools of stuff. You release stuff and you poll it for a free element. Okay? That's how you do it. Now, this code contains some crazy subtlety in some other places because yeah, I don't know whether to really go into it, but essentially, this code really contains more to it than it seems. And so if you really are serious and need to implement services for real, I encourage you to study it in detail. Because it took me a while to get it right. Actually, I got it from some other code on the web that was wrong, and then I had to sweat to fix it. Part of the fix that I had to do is the following, okay? We have this pool of results, okay? Now, so one of the things that happens by having a pool of results is this, that I can give to the activity a result, and the activity may die, boom. But the service is not necessarily killed, right? It goes on. So now there is one result that will never return back to the pool. If the activity keeps dying for stupid reasons, you will run out of your pool. Okay? And so here there is some logic to ensure that I create a results buffer from scratch in some occasions, which for my particular app were the right occasions. Essentially, if I have no empty slot, then I decide that I'm in such bad a shape that I need to recreate a new pool of results. Okay? You may have to think for your specific app whether this is the right strategy or not. Okay? Now, if everybody is still following, I can tell you what a looper is. It's not that complicated, perhaps, okay? And this will conclude, and then you can ask me all the questions you want or block me in any way you want on these so that I explain everything that is not yet clear, okay? So, sorry, how do I get out of this? No, but I had another window, but it disappeared. No, this is not it. Where is my other browser window? Did I just close it? Oh, it's here because it's full space. Okay. So in general, how do you pass messages from one thread to another in Java? Okay, so this is a simpler in a way than what I've told you, and that's why I tell you separately. How do you pass messages from one thread to another? Okay. So fine, you can do synchronized method calls, but what about the very common situation in which I have a bunch of results and I need them to pass them from one place to another place, and the two places are in two different threads, okay? So the problem here is that you don't want to do a bad implementation of these, because you don't want, for example, to, you could do these by using a synchronized list. You add an element to the synchronized list, and then the consumer loops forever, saying, well, if the list length is greater than 1, then, let me grab the first element and do something to it. No? I mean, you could write it in that way, but it would be a horrible implementation. Instead, a nice implementation is in Android, which is based on this looper. So essentially what happens is this. This looper creates a way to send messages that are in queued for you to process them one by one, which is exactly the right paradigm you want to have, right? So that there are people who can send you messages and then queue them. You can have multiple senders to you, okay? They can send them messages whenever they wish. There is no synchronization problem. All the messages are enqueued, and you, as in your thread, you can define a method that is called each time to process each message. And you don't have to worry about, sleeping if there is no message, or going to sleep after we are done, or whatever else. No, it gives you a very clean and simple implementation. So, suppose you are in a thread. This can be also the main thread, essentially. And suppose you want to say, hey, I want to receive messages. For example, this can be used to implement the reverse of what we have just done. Suppose you are in the main thread, and now you want to send messages to your service. How do you do that, right? How does the service receive messages incoming to it? Well, it could, the message, this thread has a public void run, okay? So what you do is this. You need to say, oops, sorry. You need to say looper.prepare. This prepares the looper. The looper is this organization attached to the thread that is able to enqueue and process messages. So you have to tell it to prepare it. Because the main thread, the main UI thread, has a looper already defined. Because it needs to receive all kinds of messages. Behind the scene, button touches and all these things are processed by the looper of the UI thread. But if you are not in the UI thread, you need to define a looper to be able to enqueue messages. Okay? So you define your own looper, and then you can get a handler for that message. Okay? You can define a new handler that can have a method handle message that handles the messages that arrive. Okay, so here you can do all the processing of your messages. And then you say looper loop, which means, start waiting for messages and give them to my handler once they arrive. Okay? And once you do this, once you have the handler object, you see this code produces a handler object, right? Once you have a handler, you are in shape, because you can give the handler to anybody who wishes to have it. Okay? And people can call, send message, post to the handler, or they can pass stuff to the handler. You can either pass messages or give runnables. Giving a runnable is like you give it an object that has a method run, and you're asking this object to be teleported to the other thread and run in the other thread. You remember that thing, run on UI thread. Well, that's what it was doing essentially. Okay, so you can either post runnables, so ask for stuff to be run on the receiving thread, or you can send messages to it. And there is a gazillion methods. You can look at the documentation. You can ask for things to be run if delayed. You can remove things from the queue if they are queued. You can empty the queue. You can do this. You can do that. Very flexible, the handler object. Okay. And on the receiving end, you have to implement handle message. Runnables simply run, you don't need to receive runnables. So the runnables are run. Okay? But otherwise, you need to define handle message. So that's essentially what we were doing in our code. Here, no, there, no, here, yeah? This code at the bottom, we had to define the handler. This MUI handler is a handler, okay? So what we do is that if you read all the message, all the documentation for a handler, there is we are obtaining a message and we are sending it to its target, okay? This handler is defined on the UI thread. I'll come to you in a moment, okay? And the UI thread implements this UI callback, okay, that has a handle message. So that's fundamentally what we are doing there. Okay, so this is how to implement essentially message passing between different threads in Java in a pleasant way. It's very pleasant because you get a nice queuing mechanism and all possible control over it. No? You can remove stuff from the queue if it hasn't been delivered already, and you can do lots of these things that would be extremely painful to implement yourself. So now I can give you some examples, but if you question.
I was just wondering, what would be your comment
Well, for example, yeah, let me imagine. So, I think someone of you is proposing an app, and this would be a great moment for you to give me your problem of your project and ask me how this can be solved, okay? But I know that some of you is interested in writing a find friend app in which, you know, it geolocates you and your friends, and when you come close to your friends, it gives you an alert or warning or something like that, okay? So one way to implement that app is that you create a long-running service, a started service, okay? Your activity registers itself to it. The long-running service runs in the background, okay, and checks periodically with the server, you know, the geolocation of yourself and your friends. When it finds that you're close to a friend, it generates an alert. Now, what's the good way to generate an alert? Well, it needs to do two things, essentially. If the service is, the service can trigger a notification on your Android, right? I haven't done it in detail, but I can do it. It's in the notifications. I think you have seen already that I post a notification that the service is running, but you can also post other notifications as notifications. You simply create a delayed intent and you put it there. So the delayed intent can say, hey, Kelly is also in Santa Cruz. No? So that when I look at the notifications of my phone, I see these, and you define that the target of the intent when you touch it is probably your main activity in your application. Okay, so this does not require message passing. Okay, now if your application is running though, you probably want to receive real-time updates of your friends. So in that case, you would need to code it in such a way that your application is getting, your service, I'm sorry, your service in the background, you know, contacts the server, compiles a list of friends. For example, Kelly is 1,000 feet away in that direction. George is, you know, 1 mile in that direction, etc. No? So compiles a return type that is more complicated than a single integer, but is still a single object. So you can look at the code I did and it applies. No? And then it broadcasts this return result to all the listeners, which is your app. Now your app takes these, does this magic trick of passing the message to itself. Now finally it has this message in the UI thread. Once you have this message in the UI thread that says, Kelly 1,000 feet, George 1 mile, etc., you can build a list activity that can very easily display the friends with their distances. So what you thought was something entirely trivial, like pinging the service and doing that, you know, in truth, if you want to do alerts in Android, you can see that it's really a non-trivial piece of Android. I think, you know, that this is what you notice in Android, right? That to do things for real, it requires a sophistication that you probably have not seen it in many other classes, I would guess, at least, is my guess. Maybe you do, I'm not sure. But it's more involved. Okay, so this is one example. Another example is, I don't know, you tell me, but for example, you can have a health app, okay, that monitors what you're doing. So the phone, you assume, is in a pocket, and so when you walk, you know, it feels sort of a gait periodic movement. When you have the periodic gait sensed, it may, I don't know, compile a list of threads or stuff to do for, I mean, it may compile a list of notifications that your main app wants to receive. Otherwise, let me think of other things. Once I wanted, then I didn't do it, you know. One of the things I do as a hobby is that in various places of the mountains, I have some of these camera traps for animals, right? And then I go periodically and I check on them. I've picked up very nice animals in that way. Mountain lions, bears, everything. But so I wanted to make an app in which you could be in a place, take a photo and add some notes and upload it automatically to a server, you know, to be able to geotag essentially where you see these things. I don't want to do it once I discovered that even in California there is an open season for hunting bears. The number is limited to 12, I think, but still, I didn't want to give out more information about animal locations. So, but the idea was that I wanted to build an app in which you could go around, take a photo, add some notation, and then this would be uploaded to the server, maybe with an audio file that you add to it. Okay, so this was the app to be used when you go around. So how would I use multiple threads? Well, suppose I have the photo. So the photo is when you take the photo, an easy way is to create an intent that you send to the camera. The camera takes a photo and gives you the location of the file where the photo is. So you don't have to worry about implementing a camera. Okay, but now you have a file for the photo, probably a file for the recording, and probably some text. So you need to essentially build some message and send it to the server. It's only the problem that the typical user of the app does as follows, right? I'm going around, I snap the photo, I say, yeah, blah, blah, blah. Then I shut off the phone, put it in my pocket, and continue, right? So you can't really do this in the activity. It's much better when you have this app, and even if I'm hiking, I'm probably not in connection with the server. Okay, because the cellular networks being what they are. So what you want to do is to create an activity that has a background service. The background service always runs and basically doesn't do very much. Or maybe I mean in this case it could be an intent service. Okay, there are two implementations for this. One is that you build an intent service, and in the intent you code the location of the file and the location of the audio file you want to send. Okay, this would work, and then the intent service, all it does is the upload when it can. Okay, but if you wanted to do more complicated things, because you also want your phone to sync back with the location that of animals that other people posted, what you want to do is you have a background service that actually does the synchronization. So then you need to build a bidirectional communication, right? Your app needs to be able to send it to the background service this information on the files and the uploads that you want to upload. And the service, while it's running, needs to be able to pipe back to the application a list of animal locations, files, photographs, and etc. Okay. I mean, similar thing if you want to build a client for a photo sharing app. I don't know, your Flickr, SmartMac, whatever. No. You want to keep some photos cached on the phone. Some other photos are cached on the server. If you do it well, you want to sort of optimally decide what to cache. No, so you have a service that tries to sync some amount of stuff. No, you may want to set a limit to, I don't know, 100 megabytes of cached photos. No, so that you don't eat all the memory of the phone. And then there is a UI that can show the photos, and there is a background service that notices changes to your photo collection online and to the photos you have taken on the phone, and tries to reconcile those, making sure that there's at least a copy on the server and etc. No, I mean all these things. Okay, they're all done in the end by having some server component that does the synchronization. So the real problem, in fact, is this: that if you write an app, there is no good way to say, don't die right now, just let me finish this. There is if that finish this is a few milliseconds. No? Because then in the on-pause method, you can still do some stuff. But if let me finish this means, let me finish sending this text message to the server via an HTTP call, then that doesn't quite work. Okay? So the problem is that given how volatile things are and how little you can decide about your own lifespan, these services are very useful for achieving things that you really do want to achieve before the control is taken away from you. Questions, other questions? What would you like me to do with these services now? One solution, maybe forget about them so that we can go to more pleasant topics. Yeah, I wish they were simpler. I mean, sort of what they are. How can I best help understand their views? Giving a homework. I mean, it's probably true, actually. Provided I don't give it too difficult, it's probably true. Any question? It's probably not all clear. This time I don't believe it's all clear. But what can I do is the question to help clarify this. Pieces. Yeah, no, I agree. There is no good solution. I have to tell you the truth, okay? Even when I look back at these, in fact, this will be useful to me as well when I need to implement my next service. Even when I look back at it, I go through a moment of that, oops, what's this, no? Because there's just too many moving parts. Yeah. I don't know very well what to say. I mean, there would be some need for simplification in many of these. Actually, maybe next time I should, or one of these times, I should show you how much you can do with how it is called, the App Inventor 2 at MIT, because that lets you do incredible things in an incredibly simple way. And so the contrast cannot be more striking. Maybe I should do it next time as a light introduction to the next topics. I show you how App Inventor works. Do you have any other? I mean, would you like me to try to modify this code and get it to do other things, or? I'm not sure making do more things helps. That's the problem. I mean, if I could simplify to make it do fewer things, I think that might help. Yes.
Can you explain
Okay, yeah, good question. So essentially, there is main activity, which is the activity. My service is the service. Now the problem is that the service is this funny thing, which is, it contains an on start, on create, on destroy, but it does not contain the thread that runs what you want to run for the long term. So if you just create a my service object, it does not give you what you really want, because it does not give you the ability to run for the long term. So inside my service, there is this very crucial piece of code here. My task is equal to new my service task. My thread is equal to new thread built on my task, my thread start. This is the nugget, inside it. Because that's where you create a thread to actually do work that can last long time. Okay? My service task, you see, my service task is this, right? This is my service task. So it's this file over here. My service task is the long-running thread. So it's something that that implements runnable and has a method run that actually runs. My service, yeah, so hold on a moment. My thread is a thread that runs my service task in the background. Yes?
So can you say my service like here that does spread sets up all that?
Yes, yes, I think your idea is right. My service is like a controller, right, for the thread. Because my service task is a runnable. A runnable is essentially, I don't know how to put it, but it's essentially a naked thread. So yes, it's a thread, it can run, it can have a looper to receive messages. But it's not an object that has its own create, on delete, on destroy. It does not have any one of these controller methods. It cannot return a binder to the people who might want to bind to it. So it's not discoverable even, right? I mean, if you start a thread, where is the thread now? You know, you don't know anymore, right? So you need to be able to bind to it, to have a reference to it. And so all this layer of control is given to you by the service. So this is essentially the three files. Yeah?
Can you bind the service from multiple activities?
Yes, yes.
Does it generate a new thread or is it all the same thread?
No, because if you look at the service here at the code, you know, when the service is created, you start a new activity. But when you bind to it, you know, or when you receive a non-start command, that is what you receive when somebody binds to you, I check and I start a new thread only if the thread is not already running. Because I mean, to tell you the truth, I'm not quite sure. I believe somebody could decide to write a service in a way that you start a thread for every listener. But I've never ever seen it done. So, and I don't particularly believe it's a great idea. But I don't know. I simply don't know. I've not tried to do it. Yeah.
Does it run almost keep running until it's stopped?
Yes, so a runnable, and actually not a runnable. A runnable simply has a method run, but a thread has a method that is called, I think it's called kill, or terminate, one of the two. But if you read the documentation for it, and in fact we might as well look at it if we want, but where is it? It's here. Okay. So Android thread. You can read all the reference. You know, all of this is explained, but there is a public method that says destroy. This method was deprecated in API level 1 and not implemented. Okay, and maybe destroy is all the one there is. You know, they have a lot of methods on this. I mean, run is the most typical, right? But it's not start. Suspend is also deprecated. And if you read the documentation, it explains a little bit of why this was deprecated. No, it doesn't. Sorry. I read it in some other place. But essentially, if it does not terminate by itself, it does not, you know, finalize the objects that it's controlling in the right way, and so you get trouble with the garbage collection. So this was deprecated because it could not be made to work safely for Android. Okay, so this means also, by the way, that there is a strange effect that you notice. Sometimes you say stop the service, but maybe the service is checking this Boolean flag of whether we should continue running on only every few seconds, or maybe only when the HTTP call is done. So even if you tell it to die, the thing may be still going on for, you know, some seconds. Nothing bad happens. The service is alive and the activity is no longer. In fact, services are one of the ways in which you can shoot in your foot in Android, because you know, if you make a mistake, your activity may die, but the service thread may contain a bug and never check whether it should die. Okay, and in fact, you know, it happened to me recently, but it also happens to you, I'm sure, that sometimes your phone runs out of battery and you don't know quite what happened to it. It's probably some service of some application that contains a bug and didn't see that it needed to die or something like that. Another thing that is useful to know is this. I enclosed a thread into a service by doing this complicated construction, okay? You can also create threads that are not enclosed into services, okay? If you so wish. You can just create a runnable and run it in a thread from the main activity, okay? In fact, I do this quite often. What is the point of that? Well, I told you about a sync service. No, sorry, a sync task, right? I told you also that in some phones, a sync task has a very limited pool size. Once I had to write an app that did two kind of things, you know? One is that it wanted to do something every 10 seconds. So I wanted to have an async task that every 10 seconds, you know, using the on-progress report call did something. No? This was one of my things. The other thing I wanted to do is, you know, contact the server every now and then for some other reason. Okay? So I tried to write it as using always a sync task. I was not interested in having a service. You know, I didn't want to really run in the background. I just had these, you know, asynchronous activities in which I was contacting a server in one way and doing some other thing every 10 seconds. No? And it worked perfectly on a lot of phones, but not on some phones. And on those phones, it would simply not run some of the things that it had to run, but not give any error either. And so after, you know, many, you know, hair rising, I mean, you know, you wonder what's going on, right? But then I figured out that some vendors configure some models of phones to have a limited threads pool size for a sync task. Every sync task runs in its own thread, and some vendors decided that there is a thread pool of size 1 for the async task. Okay, so that you know, if you already have something that is always running, then all your other async tasks never get executed at all. Okay, and lots of fun, as you can imagine. So the way to remedy that is to create threads, you know, as I created them in the service, I guess. And then, you know, whatever, post messages to them or do whatever you need to do to them. You know, you can use them as threads. So this also begs the question a little bit of, you know, why if you can create a thread in the main activity, why do you bother with a service? That seems such a huge monster. Okay, and I think the answer is that. Well, I don't fully know the answer because I never tried to violate the rules entirely. But essentially, if you are in an activity, you're not supposed to leave threads running much long after people stop your activity. You're supposed to try to stop them. Okay? I'm not sure what happens if you don't. I think it's considered an Android bug, and but you know, I assume that that's the reason sometimes you run down the battery because some apps are fully written and do it. Okay. What you also don't have is any level of control. That is, I want to stress that if you run a service for the long term to synchronize between, you know, my photo collection on the phone and the photo collection in the cloud, then I can, you know, the lifespans are like this. I use my activity, and which is active here, and I start my service. Okay, that starts my synchronization. Then I stop my activity because I go do something else. Then I can restart the activity. You know, at the end of my example here that I wrote for you for a small example, at the end of my activity I stop the service. But you don't need to do that. You can let it run until the user presses a button, and you can stop it only when the button is pressed. Okay? You don't need to kill it on exit the service. So, but the important part is, because I think that, you know, even a thread would stay alive even if you leave, even if it's, you know, discouraged in Android. But the difference is this, that when you start the second activation of the activity, if this is in a service, if your thread is in a service, this is a thread, right? Like a thread of, sorry, I guess. If your thread is in a service, then you can bind to it again, and you can get to it again. Instead, if you just define the thread here, that then left running as a zombie, when you activate the activity a second time, there is no way you're going to get a reference to that zombie thread. No, I mean, the variables that were here, off, they're gone now. This may be 1 hour after. Okay? So a service is essentially a container for long-lasting computation to which you can bind when you wish to bind. And instead, it's perfectly true, and I've done that you can spawn activities for spawn threads from the activity. I've done it because a sync task is not fully reliable. But when I do that, I'm very careful when the activity executes its own on destroy or on pause or on stop. It's a little bit your choice, I guess. But when it executes one of those methods, you need to keep a list of all the threads you have created, and you need to set all their flags so that they will self-destroy. Because if you don't destroy them while you have a reference to them, there is nobody else who's going to destroy them for you. That's the real problem. Okay? I mean, I know it's complicated, so let me know, other questions or other things I can do for you, or also wishes for next time. You can post them on Piazza, and yes? Sorry? I think the answer must be yes, but I wouldn't know exactly for what. So you're asking essentially, is it useful to write a service that does not contain its own thread? I'm sure that there must be a reason. Oh, no, I can tell you the reason. I believe, okay, this is a belief because I've never done it, so I never trust what you haven't tried. But I think, suppose I want to write a library, okay, and I want to write a library that runs in your thread, so that you can call me, and he can call me, and she can call me too, okay? So I can have many callers, but I don't want to tell you which class I am. I just want to return you a binder to which you can call me. Okay? Then you can write a service for that. It gives you a way to encapsulate, because people can bind to a service, and so people can bind it to the library, and it's dynamic. In fact, I think OpenCV, this Open Computer Vision package available for Android, is implemented in that way as a service, but it does not have its own thread, I believe. Okay, it's only that if you try to bind it to OpenCV, if OpenCV is not installed on your phone, your intent when you say start service OpenCV, it probably comes back saying, hey, I'm sorry, but there is nothing called OpenCV. What shall I do? And otherwise, it wouldn't be able to compile your app. You see, it gives you a way to dynamically bind to a library without compiling it into your source. You see the point, right? You can bind it at runtime, and you're given this binder, and then you can call the binder at runtime. That's the beauty of it. It gives you a method for runtime binding of code. Yeah. So for that reason, I'm sure it's done as well. I'm not sure, it's probably not something you're doing in your projects, but yeah. Yeah, so this gives us one of the first examples that I'm sure you have seen of code that you can really bind into your own code at runtime. All the other code, I'm sure that goes in your projects that you have written so far. I'm pretty sure that this was part of the compilation link unit, at least, that you had. Even not, the service can come from somebody else entirely, and you can launch it at intent by which you want to bind it with. You receive a binder, and you can call the binder. Ta-da! That's it. Okay, let me know what you want to do next time. Otherwise, I'm planning to move on to sensors. Please remember, next Tuesday at 2 in a lab in E2, there is going to be this person from Plantronics visiting, presenting these new sensors. That I think it should be quite interesting, actually. So let's. I'll be there, and show up if you are interested. Okay.